In this video, we are going to look at an application of derivatives to business and economics. So the three functions that we talk about often when we're applying calculus to economics are cost, revenue, and profit. So the cost C of X is the cost function, and it's the cost of producing X units of the product. R of X is the revenue generated by selling X units of the product. And then P of X represents the profit for selling X units, again, of the product. And we define P of X, that profit function, to be the revenue minus the cost, how much you're making minus how much your expenses are. Now, if X units of a product are sold at a price P per unit, the total revenue R of X is given by this function R of X equals X times P. It's the number of units times the price per unit would give us the revenue. And we often define P, the price is called the demand function. Okay, and the price is also going to be determined by the number of units sold. So it's a function of X. And so we often more write R of X as X times D of X. So you'll be given the demand function and you may have to find the revenue function. So one thing we're often interested in is producing one more item. So if we have C of X as our cost function, economists are often interested in approximating the additional cost that it is incurred if the production levels increase by 1 unit from X equals A to X equals A plus 1. And the increase in cost would be the change in cost, and that would be the cost at A plus 1 minus the cost of A. So just for like example, if we have a graph of the cost function, usually the cost increases as the number of units increase. But if I have this unit A, and then I go 1 over for A plus 1, what we're really doing is to find the additional costs incurred. We're finding like the slope of that secant line, but the difference in X is just 1 because A plus 1 minus A is just 1. And then the difference in Y is like that C of A plus 1 minus that C of A. And that gives us the cost of 1 more unit. So it represents the cost to produce the A plus 1 unit. So we interpret it again of 2 ways. One way is saying it's how much it costs to produce the A plus 1 unit. And the other way is to say that it is the additional cost incurred by increasing from A to A plus 1. They might ask it either way. So then we have this idea of marginal cost, and marginal cost is a way to approximate this change in cost from the A to the A plus 1 unit. So the derivative C prime of A is called the marginal cost at a production level A. And C prime of X is the marginal cost function. And C prime of A is approximately the additional cost that is incurred when the production level is increased by 1 unit from A to A plus 1. So this derivative is approximately equal to the C of A plus 1 minus the C of A. And often the derivative is a lot less work to do, which is why economists usually want to use this to approximate it instead of actually calculating C of A plus 1 minus C of A. So for an example, we are going to look at this cost function. So it says, suppose the cost of producing X items is given by the C of X function. It says, what is the extra cost of increasing daily production from 50 to 51 items? Okay, so again, we are going to find C of 51 minus C of 50. That's the additional cost for it. So again, a lot of times easier to do is just using your calculator. So let's type that function in our calculator to save us some time. So we are going to go to y equals, if you have anything in there, clear it, and we're going to type this cost function. So we get 0.005 x cubed, and then you use the caret and then the 3. Make sure you arrow over to get out of the exponent, minus 0.5 or 0.5 x squared, and then plus 28x, and then plus 300. So then the easiest way usually is to go to table, but first go to second table set and make sure that the independent is on ask. Okay, so if it's not, go to ask and hit enter, and then hit second graph for table, and then type in the values you want. So I'm going to type in 51, and I'm going to type in 50. And a lot of times this rounds it. So for more accurate, if you actually highlight it, you'll get the more accurate answer. Okay, so we get C of 51 is 1090.755. And then our C of 50 was 1075. Okay, and that is going to be the difference in costs. And we subtract those and we get 15.755. Let me rewrite this because once I made it bigger, it's much messier. Okay, so we get 1090.755 minus 1075. And that gives us 15.755. Usually because this is money, we do 2 decimal places, so 15.76. And the units are dollars. So that is the cost to increase from 50 to 51. And then it says, what is the marginal cost when x equals 50? So that would be C prime of 50. Again, we always first have to find C prime of x. The marginal cost always means the derivative. So we will take the derivative of this. So we get 0.005 times 3, which is 0.015 x squared minus 1 x plus 28, and the derivative of 300 is 0. We're going to plug in 50. And again, if you wanted to type this into your calculator, you could do that as well, or you can calculate it this way. And that gives us 15.5. So again, the marginal cost approximates this, and in this case, they are pretty close. And just one more thing about this, if they ask you to interpret the marginal cost or to interpret either one, for this, we would say it's the cost, again, to produce like one more unit. So this would be the cost of producing the A plus 1 unit. So it's the 51st unit. Okay, or the 51st product. Okay, so that is the marginal cost.